going back to what we do, aside from the community events for which you are here today, we also do hands-on product management work as interim or on specific projects, as well as pro bono or advisory things. So without further ado, I'll leave it to the talented Yetunde and Timo to take over from here. They are from QuantumBlack. Yetunde working more as a classical PM for internal products, and Timo is principal and engagement manager, and has a very interesting background. You should check his LinkedIn. Cool. I'll leave it over to you, folks.
Cool. Thanks for the introduction. And Yetunde and I are very grateful for being here tonight and getting to present what we do at QuantumBlack. Maybe before we start into content, just a brief introduction on the two of us. And Yetunde, do you want to kick us off?
Yeah, sure. Hi guys, I'm Yetunde Dada. You can just call me Yetu. On Twitter, I'm Yetu Dada. I'm a principal product manager at QuantumBlack. I'm originally from South Africa. My background is actually in mechanical engineering, but really a passion for design and solving people's problems means that I get to do it in my day-to-day work. I'm going to be talking to you about Kedro. It's a data science and data engineering framework that helps essentially everyone write better code, so we have reproducibility and maintainability at the heart of what we do. I've been at QuantumBlack for the last 2 years, and I checked yesterday, 4 months. So it's been an amazing journey so far. I'll hand over to Timo.
Cool, thanks. Yeah, my name is Timo. I'm a principal of QuantumBlack. I work on our client-facing side, which means that I get to develop products together with clients, building on the many amazing tools that Yetunde and colleagues are building at QuantumBlack Labs, and also a couple of bespoke assets that we have built. My background is actually in medicine, and after med school, I joined McKinsey for a couple of years, actually in the Berlin office. Yetunde and I, we are both based in London now, and I've been at QuantumBlack since 2019 now. Yeah. Cool. So much on us. What we want to talk about today is 4 things. Number 1, quick introduction on QuantumBlack, who we are, what we do. Secondly, I'll tell you a little bit about how we work internally and also with our clients. I'm going to hand over to Yetunde, who's going to be the main thing for today's presentation, talk to you about Kedro, and then I'll close with a couple of reflections on building machine learning products. Great. So QuantumBlack. QuantumBlack actually started in Formula 1 and about 10, 11 years ago. The 3 co-founders of QuantumBlack met. They were working in different areas of Formula 1, and they saw that the work that they were doing there, which was building much of the software infrastructure for Formula 1, was applicable in many areas of business. Also today. And McKinsey acquired QuantumBlack back in 2015, and has been an amazing journey since then. When QuantumBlack was acquired, I think it was about 30 people. We are over 500 colleagues today across the globe. And we are essentially applying data analytics and design to client problems across industries. We have, I think, worked pretty much in any industry that you can think of, from retail, healthcare, pharma, even Formula 1 again, where we have our roots to basketball and football, I believe even, and across pretty much any business function you can think of, from manufacturing to sales and marketing, pricing, finance. Just as a brief overview on QuantumBlack, so our main hub is in London. That's also where QuantumBlack was originally founded, but you can find us in any major geography. We are organized around different guilds internally. principally data science, data engineering, design, and tech delivery, respectively architecture. The background of many colleagues is within broadly data science. Lots of people have PhDs in mechanical engineering, mathematics, physics, and the likes. And aside from client projects, we have a big crew of our colleagues are working in what is called QuantumBlack Labs, and Yutunde is going to talk with you a little bit more on that, where we are developing a lot of tools in-house. And we are also doing a lot of R&D, in particular at the moment around explainability, automation, and causation. So how do we build products with clients? So that's basically my day-to-day. We have refined the process over the last 10 years, which principally builds on 3 key pillars. And those pillars are what we call process, people, and technology. And I'm just going to walk you through each of those 3 key elements. So the protocol that we are using is called the 5 I's for ideation, intelligence, inception, interventions, and independence. And if you think in discovery and development, the discovery bit would very much be ideation and intelligence, the development, inception, and intervention, a little bit of independence. So when we first start with a product, we typically start with an organization's value chain. We look at different user problems or potentially high-value use cases that the clients might already have in mind. And we try to come up with ideas how we could potentially address those problems with analytics and design, principally. In the next phase, we would take a prioritized list of those, try to measure the value at stake even further, and then also start to understand what the requirements would be in terms of data and also other internal capabilities to build that. And the intelligence phase is typically where a lot of the product team or the data engineering, data science, and designers come on board and help build the initial pilot or MVP, which we further refine in the inception phase. So that's typically where we get all the raw data in and we start building the data pipelines, do all of the feature engineering, and then also the data science modeling. Once we have done that and we have a running product MVP, we would move to action and start to implement that actually in the business. And that's what we call an intervention. And the last step, independence, ensures that what we have built at the client can also be maintained and further developed by the client. So that's where we transfer skills and technology fully into the business so they can fully own that. In terms of people, that varies really by what we are building. In any setup, really, we have an analytics EM, so that's the role that I'm typically playing. We have data scientists and data engineers. And many of the other roles that you see here may be part-time or maybe many, depending on the use case, really. So we have done smaller use cases from a couple of people to large-scale product development projects across Europe with 30, 40 people. So it can vary quite a bit, really. But QuantumBlack has all of these colleagues in-house, and in many cases, we are also supported by colleagues from McKinsey, in particular, if we need specific industry expertise. In terms of technology, we are very agnostic, really. We use whichever tools best fit for the problem that we are trying to solve and also for the infrastructure that the client is already using. We are using a lot of open source software, part of which is displayed here. I think the third-party software that we are using is also very commonplace. And then we have a couple of bespoke tools, one of which is open source, which is Kedro, which you will hear a lot more about in a second, and some of which are currently in development, some of which are already live, but not necessarily open source. Yeah, and that's a quick run through on our 3 elements. And with that, over to Tunde.
Cool. So what I'm going to be taking you through is essentially an understanding of the problem space that Kedro fits itself in, and really we'll touch on like aspects that the machine learning product workflow has. So you can head over to the next slide. Cool. So in terms of like how we build product within QuantumBlack Labs, QuantumBlack Labs is a series of designers, developers, and product managers that really help first understand how our teams are working on client engagements and how we can best actually solve problems they have while trying to do these design engagements. Timo mentioned that a lot of this is actually based on something that we call the protocol, which is essentially captures our team's best practices. It's like 180,000 words of people writing how they deliver things. We can go over to the next slide and I can give you an example of some of the questions that are asked there. So it'll be things like, we need a way to rapidly create an analytics environment for our clients, or the team needs a way to track and validate hundreds of hypotheses. We need a way to share reusable code to accelerate future engagements. All of these questions have been asked in the protocol, and we've made notes. We've been able to make notes on their workflows, notes on the reasons why they're not able to do these things. And this actually results in, it actually forms the basis for where we decide to prioritize our effort to actually build things. We're going to focus on a specific one though in this series, which is we need to ensure we're building a data pipelines in a production state. And that's essentially where Kedro actually fits in. So we can go over to the next one. So it focuses specifically on the problem statement of we need to ensure we're building data pipelines in a production ready state. The reason why you'd want that is because it makes them easy to deploy. So I'm going to talk you through a scenario of how our users get themselves into problems in the world where Kedro does not exist. So what happens is typically everyone's excited. You get, you discover that you're going to be solving some sort of problem with machine learning. You have access to some sort of data sources. People decide to take a dump of the static data, or maybe like a month's worth of the data instead of like 5 years. So we now take that static data. We work in a tool called Jupyter Notebooks, which is a interactive development environment for data scientists. They quickly create some sort of output, which you now can see the results of this output. So it comes out in Excel sheets or CSV. Everyone's very excited about the way that this model is performing and working. But next, we decide that, hey, we actually want to think about how we're going to deploy it. And this is actually where the next stage comes in. Timo? So you think of like, hey, how are we actually going to deploy this so that people can actually access these data sources? So we quickly wrap these things up using a tool called Flask and have some sort of API that people can call. Done. We can go next. And now we find, hey, remember we trained our data on 1 month's worth of data, but we actually need to be using new data that comes in. It's not enough for us to be using December's results. We now need to be using January's results. So now we start to add in an additional step where we're starting to feed in this new data. But we also need to check that this new data is not actually going to be changed, has some sort of like change data format, because that will break our pipeline. Our pipeline is built with the static data model in mind. So now the pipeline starts to get a little bit more complicated. And then we think of it and realize that, hey, we've been using a Jupyter Notebook this whole time, but we've actually far outgrown our need for the Jupyter Notebook because we have so many other things to consider in our workflow. Maybe we have a feature store, which is actually simplifying how we deploy features for our training model. Maybe we have to think around unit tests as well, so we're writing robust code. And with all of these things, refactoring is actually the cost, because you have essentially created a code base that you have to completely start from scratch and rebuild because you can't use any of it. So we go next. And even more than that, realizing that we have to add in things like an orchestration layer or metadata layer. Orchestration specifically means like, maybe this pipeline is supposed to run at 7 a.m. on a Monday every week. How do we make sure that it's doing that on time? And how do we make sure that, you know, this thing is all monitored so that if something fails, I know what to do. When we look at robust machine learning systems, that's something you'll have to consider. And when we look at things like deployment in Kubernetes, it could be on any type of infrastructure that you have to be deploying this model so that it runs in proper processing time, because you can't be waiting 2 days for your results, perhaps, depending on your use case, and maybe you need it in a few hours. So with all of this, I guess we can go to the next slide. There's a real thought around what was the intent, and this is what you need to learn as like a machine learning product manager. What was your end goal with writing code? Was it because you wanted to produce some sort of like quick insight and put it into a report deck so that senior leadership, you could make decisions around how to proceed on certain objectives? Or are you really thinking around what we call machine learning products? This is data science code that needs to be rerun and maintained. And when we say rerun and maintained, someone is going to be looking at that code later on to work with it. So you really need to think around, how is it well structured? Where does everyone know how to work on that specific code base? Because they're different building styles if you think of it. In the one example, we have the build of a shack. It's very quick to set up that home environment to live in. You kind of assume that no one is really, the wind is not going to come and blow that structure over. But when we think of like skyscrapers and scaling machine learning systems and building robust machine learning products, which is what we need to be doing in industry, you need to approach the building style in a different way. And Kedro, if we now look at actually where it fits, is essentially your ability to still work in such a way that you could produce an insights report, but it can actually turn into a machine learning product. So you get the benefits of both worlds, speed and robustness. So we can go over to the next slide. And cool. So the users of Kedro are data scientists, data engineers, and machine learning engineers. We think of Kedro as a machine learning engineering framework, and it helps you produce reproducible, maintainable, and modular data science code. In that example that we had, you would have seen in terms of the building styles, Kedro is actually the scaffolding, if we look at that building. It is essentially the place where it allows us to scale the size of the building or scale the size of your code in a very easy way. And that's what our users all talk about it. You'll also see that it's placed well in industry. Our users keep placing us in the bucket for MLOps, machine learning operations, which essentially looks at like, how do we make robust and reproducible code? We think about all those things. So you can go next. So I can maybe actually talk about the reasons why we continue to use Kedro. We have a consistent time to production because now we're making fewer mistakes on, you know, I spoke about that process of taking code and having to completely rewrite it because we realized the Jupyter Notebook was not fit for purpose. We also get benefits of code reusability, which fits right into the way that we work, because now we're benefiting from reusable code stores because all our code is modular and can be reused. We're talking about increased collaboration as well. Data scientists, data engineers, DevOps teams, machine learning engineers are all working in better ways because we have essentially a level or a standard that Kedro represents in terms of software engineering best practice, and everyone gets to that level because they learn through Kedro, one, and then two, the standards are also embedded into how code is written in Kedro. And then this is one of my favorite parts of it, we get upskilled developers. Our users are learning more about software engineering principles and how to apply them to machine learning code, which is never a bad thing, because that's the way that industry we found is moving. There are fewer places being made available for code that is not robust. So when you're producing these data and machine learning products that is something that you have to think about. How are we going to maintain this thing in future? How do we make sure that this code base, we can trace errors in this code base because there's proper logging? There are all sorts of considerations you need to make for that. So we can go next. So in terms of demo time, what I'm actually going to do is pop you a link in the chat, which has essentially a link to a Kedro visualization. You get a pipeline visualization essentially for free when you write code in Kedro. Data scientists, data engineers use this as a tool to talk to business stakeholders or PMs around how a specific code base is structured, which data sources they were using, what machine learning principles were being applied. So you can definitely check that out in your spare time. That's essentially the front end of Kedro. Most of the work actually happens in the back end with the developers. So yeah, that's essentially Kedro in a nutshell.
Cool. Thanks, Yetunde. And I'm just going to close with a couple of reflections on building ML products day to day with our clients using Kedro and other tools. 3 things that I wanted to highlight in particular. Number one, what I think gets a lot of attention in machine learning is the algorithms or the ML code, which you can see here on the left-hand side in this little blue box in the very middle. When in fact it's really just like one small part of the overall system. So we are in our day-to-day and also in the horizontal products like Kedro that we are building, we are putting a lot of thought and energy actually in the entire end-to-end system, also around monitoring, feature extraction, how we collect the data, how we ensure that we get stable results over time, etc. So everything that you would today probably also subsumize on the point of MLOps. The second point that differentiates ML or generally data products a lot from, let's say, products that don't use data and algorithms as heavily is that they come with their own set of challenges that you don't necessarily find in many digital applications around data biases, gender being one that's often being discussed, or race also, data drift, or also like the decreasing value of new data sources. Something that we often find actually when we are working on projects is that there is a lot of data that you may want to add, but whilst the added value of adding one data source might be very high in the beginning, and the cost stays relatively stable often of adding one additional data source, the value decreases quite asymptotically, because the data corpus, so the commonality across data actually is quite high in many settings. So it's just something to be aware of. And the last thing, and a very important point, is the ML that you are building depends very much on the use case. In many use cases that we are building, like an 80% accuracy is quite fine because a human can override it, or you don't need to be 100% correct. In the example that I put up here, for instance, like with Google search results, right? You are still the person that actually clicks the links. You're not just being presented one, but actually an array of choices given the words that you put in. However, if you are riding like in an autonomous vehicle, for instance, you don't want to be 80% correct if you're at a crossroads, for instance. So this comes down a lot to how you actually handle edge cases in machine learning models, and getting to 80% may just take you like weeks, sometimes months, but getting the last 10 to 20% in ML can, in some cases, even take years. So that's just something to be aware of. How much accuracy are you aiming for in your product? And yeah, that's it from QuantumBlack, and Yetunde and me. Thanks for having us.
Great, thank you very much, Timo and Yetunde. we are now ready for questions. Oh, thanks Yitunde for some links onto the demo and open source. Great. We are quite many people, so I would suggest that please type your questions in the chat. I will also be looking at our YouTube stream. So if you're watching us on YouTube, yeah, people already complain on YouTube that there is no link. I'm going to post it now from Zoom that you all have it. And here are the links on YouTube. Please feel free to write your questions there. And also here. But if someone is, while everyone is writing, someone has a chance to say question with a voice. Oh, there is a question already. How is Kedro different from Airflow? Does it support streaming?
Good question, and I'm actually wondering if I can actually show you where Kedro fits into that space. So we solve different problems, essentially. The problems that you're using Airflow to try and solve are essentially orchestration issues, which is how do I make sure that my data pipeline at that point is actually running on time? How do I make sure that there's this thought around like how do we monitor these things? The Kedro essentially forms the scaffolding for it. If I can share screen, I can actually show you briefly what I mean.
Sure, go on.
And this is essentially where Kedro fits. So Kedro essentially scaffolds the activities of ingesting raw data, cleaning and joining the data, engineering the features, training and validating the models. And then when we think about deployment, we look to tools like Dagster, Airflow, Prefect, Luigi, Flight, and many more to actually deploy your pipeline there. We focus really on the whole thing of how can we create reproducible, maintainable, and modular data science code. And we find that those tools that are really good at deployment, they're called orchestrators now, will tell me things like, you know, what time will this pipeline run? How will I know if it failed? And that's what we use Airflow for. You will see though, we've just actually rebuilt our Kedro Airflow plugin. So it should be out shortly. We've been working with the team at Astronomer to actually build out deployment modes for using both Airflow and Astronomer 2. So you should look forward to that. Essentially, it gives you the freedom of being able to write your Kedro pipeline with a software engineering best practice, and then choose how you want to deploy it, and you can use Airflow in that case. Cool.
Great, thank you very much. Vasilia, I hope it answers the question. Right, if you have more. And thanks to those who who switched on the camera. It's very nice to see you guys and some familiar faces as well. Yeah, Vasilia says, yes, it's helpful. Great. Any more questions? Everyone is being a bit shy. So you can also switch on the microphone now and say it with your voice.
I have a few more, if nobody wants.
Go on then.
Okay. I'm a data product manager / data engineer, so it's a very familiar topic to me. And so usually when I work with a client, I work as a consultant now, I have an issue of scoping initially. I'm curious how you approach that, because especially for machine learning projects, I find that most of the business stakeholders don't really know how to approach them because it's a bit abstract. So how do you actually decide on a scope of the project? How do you pick the exact data points you're going to use? Because there is a lot of data swamps and a lot of data issues in big corporations, and the amount of data is huge. So yeah, those are the two for now.
Yeah, good question. So if you remember back to the 5i process that I showed earlier, they vary by stage. The length of each varies. So I would say the first bit on ideation probably takes us like a week or two, maybe. The second bit, where we actually spec out more the features and the data sources that we want to use, probably takes up another maybe 3 to 4 weeks in most cases. So I would say in like maybe 4 to 5 weeks, we have like a rough idea of like what we build and like what data sources we will most likely need and how easily we can get them on, how quickly. And also like depending on that assessment, principally in a couple of other factors, whether or not we think there's the use case would be viable essentially. So typically after, let's say 3 to 6 weeks, we can say with a high degree of confidence whether or not it can be built and in roughly what timeline. And roughly what timeline after those initial few weeks, I think that is mostly past experience, to be honest. I'm not even sure how many projects we have done at this stage, a couple of hundreds, so it's by experience. And in particular for the use cases, and this one I would add, that we have done repeatedly and where we have assetized good parts of the code, we will have a much better perspective, because then the unknowns are much smaller, obviously.
Great.
Thanks.
Thank you, Timo. There is now a question from YouTube. What are the biggest challenges you come across when preparing data for machine learning models? I guess it's more to you, Tunde, probably.
But actually to both, I guess. So some of the initial problems that you might find in terms of preparing data for your modeling approach, we actually have a category of like data risks. So really thinking, I think Timo mentioned it around like what type of data bias exists in the data set. What kind of missingness as well exists in it? We focus more on a hypothesis-driven approach to solving our problem. So it means that we'll come up with a hypothesis that, okay, let me think of an example. We believe that this certain customer group is our highest, maybe our highest, most valuable customer group within a bank or something like that. And you need to prove with the different data sources that you have whether or not that's true or false. With this in mind, it's also you have to keep in mind things like how easy is it for us to access certain data sources as well from the different data users that we have, the different data owners that we have, that's one. And then two, what is the data quality when it comes into the pipeline? Because if we find, for instance, that, hey, the missingness in this data is like 60%, we might not be able to use it in our machine learning pipeline at all. But I think Timo might actually have some more insight here.
Yeah. I think quite practically, I think oftentimes like data availability, like you would like to do something, but there's actually no data for that, or you can't join the data together. That's relatively common. Oftentimes also if it's in particular, if we are working across countries, how quickly we can get the data from different data sources across different business and functions. So you need to bake in quite a few weeks, sometimes even months, for the data to become available, depending on where you have it. And I think one common, I don't want to call it like a misconception, but like, I think a sense that many people have that don't work day to day with data in ML is the more data you put in a machine, the better it's going to become, because you just have more features. So naturally, at some point, it has to come to like the 100% accuracy or something like that. I think what we rather often find is there's a few really key data sources. And if you extract the right kind of features from those by asking, as Tunde said, like the right hypotheses, you get very quickly to those 80%. And then oftentimes the additional workload you have to put in to get like to 85 or so is often not really worth the effort. And rather takes off speed. I think that's the key things that I can think of that we encounter.
Thanks. Kashika, go on.
Yes, so as Timo, you mentioned that we have different data sources available for a particular data. So does Kedro cater to that need that you can actually process the data from different locations? So how do you manage that in Kedro? Because in Jupyter, you can actually have a folder and then everything is good to go. But how do you manage that in the framework Kedro?
Sure. So Kedro actually has this principle of what we call a data catalog, which is essentially a register of like all the data sources you could possibly need. I'll show you where it is in the documentation as well, so you might be able to find it in your spare time. I will share screen now. What it allows you to do is essentially call those data sources into a Jupyter notebook. But it also does give you the freedom to call from data sources that might not even just be in your data folder on your local computer anymore. They might be cloud storage data sources that you're now using. So if we have a look at this guy over here, you'll see over here, you specify this in configuration. So this over here is a table called bikes. And it uses pandas to load it. It's a CSV data set, and you see the file path for it is data01 bikes CSV.
I see. Okay.
We could also use it for S3. We could load pickle files if we wanted to. We could use Google Cloud Storage, matplotlib files as well as support for Spark tables. When you're actually calling these files in Kedro, in your Jupyter notebook, there is a section around this, which is, I'll scroll down here. This is actually how you'd call the data. This is actually how you'd load your data set in Kedro. So there's no more read_CSV. You'd essentially just call catalog.load and load the name of the table that you were looking for.
Okay. That's nice. Thank you.
Cool.
Great. Thank you, Tunde. Here's 2 more questions from YouTube. First is, what is on the roadmap for 2021?
Cool. So roadmap for 2021. So we've been looking into a few user problems that have been raised. One of the recognized patterns that Kedro is used for is they use another tool called MLflow. It was a project by Databricks that was graduated into the Linux Foundation, and it helps in the data science workflow with something called experiment tracking. It's notable in Kedro that experiment tracking is missing, and the workflow still with Kedro MLflow is not as optimal as it could be. So we will be looking into improving that one significantly. You also will see thoughts around, we've been hearing people's ability to do data lineage as well. In the demo that I shared with you, you'll see already that Kedro allows you to do what we call first level data lineage, which is where you can see which tables were used to form which tables. But people still want an ability to go one level deeper and see columns because of this whole thing around explainability of your features and being able to trace how features are made. So we will be looking into that one as well. And then there's just a host of things that we look at. It's an open source project. So really being able to improve the community and have users access us in ways that they can't, because right now we get messages on like Twitter and like LinkedIn, sometimes GitHub issues, which was the channel they should be using. So we will be opening up a community channel as well that you can look forward to talking to us too.
Cool, thanks a lot. There are actually 2 more. I see that Malte has a question, but I will first take some from YouTube. I think there are 2 that are very connected, so I'll read both of them. First, what approaches do you take to help clients get to independence, especially if they are not too technical? And how do you ensure model maintenance once they reach independence? And second, to the curious customer, it often requires a large degree of explanation to fully explain what is happening in the ML model. What's the tolerance of your customers towards not fully understanding? And if there's some special process that you use to help them tolerate it or understand it?
Okay, cool. Couple questions. I'll start with the first one of independence. Then, okay. So, so with independence, there is, I would say there's like 2 key aspects typically that we have. Number 1 is technical independence, and secondly, what I would probably call like independence from us as people. So in technical independence, as much as we can, like from day 1, we try to work in the client's infrastructure. So if they use AWS, we use AWS. If they use certain specific tools for data cataloging or whatnot, we try to integrate those as well. Because the more we build, if we didn't do that, we would have to revisit a lot of the code and architecture that we built in the first place and take it apart towards the end of the project and rebuild parts of it. So that's something we try to avoid. on people independence, so we typically work jointly with client teams. That may not be the case for every role, but we try to ensure that for the key roles. So let's say if you have like a 10-people team of like 3 data scientists, 4 data engineers, technical architect, a designer, and maybe like a product manager, we try to replicate it also on the client side. Even if it's not a full number, even if they just have like 1 data scientist, 1 data engineer, etc., we try to have at least a couple of key roles represented, and then we have an approach that we used to call build, operate, transfer. So where we build something, we operate it jointly with client teams, and then we transfer it completely. So if you think about like the analogy of riding like a bike, like a tandem, like we are basically riding initially. People are more observing, then you're riding together, and then the client teams ride mostly, we more observe, and when we are comfortable that it actually works, we are gone. That's the ideal scenario. On model maintenance, so I think that goes mostly back to what I was saying just previously. So we try to ensure that they can basically maintain it both from a technology and from a people perspective. And the maintaining model performance then comes back to having like the systems in place technologically that you can ensure that model performance stays stable, that you don't have any particular shifts, for instance, in the data frames that you're using and so on. For model performance, we have built a tool in-house which is called Performance AI, or short PI. Yetunde, I don't think it's open source, is it?
No, we're part of the small roadmap items for Kedro. One of them looks at actually full integration of Performance AI. It's the experiment tracking tool, so really focused on that experiment tracking problem. So it will be open sourced.
Cool, yeah. But as I think many of you are aware, there's like many open source tools that can do that. So we try to use those with clients so they can take it over fully. And then Victoria, I think I lost the last question.
Yeah, it was about clients maybe not fully understanding what's happening in this ML model. Does it have some impact? Do you do something specifically to help them understand?
Explainability, yeah. So to the extent we can, and so I would say like there are use cases where it's important to have explainability. There are use cases where it's less so. So, and where it's actually not even decided by the client. But for the use case, let's say where there is a client interest or where it is actually actively required, let's take for instance Yetunde's banking case or so, right? So you might have like credit scoring risks or something like that, right? You may want to know why a particular customer hasn't scored particularly high on a certain metric or so. So let's say use cases like that, we try to build incorporating explainable AI from the start into it, really. And in many cases, what we have seen also that even for the principal use case was not necessarily insights. Many users on the business sides would use just the explainability output of the models as a tool, essentially, right? So if we take the banking use case again, the actual users might be the front office staff who has to approve credits for customers. But then you may even have, let's say, risks analysts, or even marketing personnel in the back office of the bank. They may be interested in, well, are there certain segments of customers, or what's actually driving poor credit risk for certain customer groups and so on. So they can market to different groups, or they can devise their risk management systems and so on. So that's something we have seen quite often, I would say. And yeah. At least from the projects that I've done, I can't remember any where we have struggled with putting explainability into the models.
I think even just building on it, it's important to just realize that your clients are end users. So really, it does help them when they're able to trust the models. And one of the ways that you can build trust is obviously thinking around like how explainability will look. It's something that on our projects is negotiated in the beginning. So you have to look at like the extent of the explainability requirements. You have to look at whether or not there's performance issues that come with it or legal reasons why they might need it, and agree with it, because it does help with define quite a few things in your project, like for instance, your modeling approach. Because there's a part, I think Timo spoke quite well to it, where you can use explainable AI tools. For example, SHAP is a frequent tool used by data scientists to help make black box models more interpretable. And there are a few other tools that you can use. GA2M, which stands for generalized, I will find what this one is called, the full name for it, which is generalized additive models plus interactions. So you can also use those ones as well as kind of like interpretable machine learning. And we do also have tools internally that users can use. But also, if there's a hard line requirement where you can't even use the black box models, I have heard of projects where they've had to go for a simple linear regression model, which, I mean, it's not the end of the world. But there's a hard line requirement for on the legal side for interpretability. But remembering really that your clients at the end of the day have to use and trust your model, and explainability is one way to build trust in the model. So if it's needed, do consider it in the beginning of the project.
Great, thanks a lot. Let's take the question from Malte. He's waiting for quite some time now. Malte?
Yeah, can you hear me, guys? Thank you for the talk,
Yeah.
First of all. I have two different questions. Like one is more on the technical side and touches on what you just said, Yetunde. So we had in the couple last years, I would say, some extent like a more notorious shift towards like the whole topic of deep learning, and as complicated as possible and as shiny and nice as possible. So do you see also the problem with deep learning models, that they are more difficult to handle, especially in ML ops? And because of that, do you also see that you more and more use maybe simpler models, for example, regression models or linear models, so that you can really use them and explain them to the customer? So that would be interesting. So the deep learning to simpler models. And my second question is regarding scoping. So I'm working in an environment where everything is super hyped on like Scrum, and let's use Scrum everywhere we can. And I feel like that it's pretty difficult for topics like ML or machine learning to use Scrum, because in many cases you rather like time box your approach, I would say, for machine learning, and you can't really estimate the complexity of pre-processing in advance. So how would you handle machine learning in a Scrum environment overall? These would be my questions. Thank you, guys.
I could probably take the deep learning one, and then Timo, you might want to take on the applying Scrum and Agile principles to data science projects. So with the first one, deep learning models, we obviously know that there's an influx of the way that people consider how to deploy deep learning models in production, but it still goes straight back to like the first principles approach, which is like, why are we using a deep learning model, and who is going to be the end user of this model? Deep learning models are, I think, quite preferable in applications where we need either high accuracy or it's a very difficult machine learning problem to solve. And in those cases, it's a negotiation with the client that this is the best way to approach this problem, and therefore we use it. So in cases like that, it's still an upfront discussion with the client on what modeling approach do we use, and we agree on that before you proceed. And then in terms of working, we have an amazing tech delivery team that works to actually think on how do we deploy these models so that they run and function in production, fully accounting for the fact that they need to still be performant models. So all those trade-offs kind of need to be made while choosing which machine learning approach you'll need. And then I can maybe hand it over to Timo for like thoughts around agile work, agile principles for data science projects.
Yeah, cool. Thanks. Yeah. So I would agree with you, Malte. So in many, so if you scope out the projects, I think there are phases that we are definitely more comfortable with or confident with because we have done them before or they seem relatively easy. And then there are elements of the problem that we maybe haven't done before or that are much more complex. So I've done the time boxing approach also with teams for the elements that have been like very complex, and typically in that case we have tried a couple of different approaches to correct the problem, and then we either like succeeded at the most sophisticated approaches we want to go with also, or we went for something more pragmatic. And that's typically like very honest discussions that we have with the clients, even when after the first initial weeks we have spec'd out the features that we would like to build and the model types that we would like to test, that we agree with the clients, we have transparency on the different approaches that we could take, that we will fall back onto if the more sophisticated ones may not prove to be feasible because of modeling, because of data or whatnot. And that I think that transparency is key, because like then nobody is going to be disappointed that certain approaches weren't possible even before they were tried, and you still have a way to solve the problem. I think maybe one more afterthought on processes for data science project. I think that combination with Scrum and like time boxing really complicated parts works. I think something that doesn't work as well is if you have more traditional waterfall planning, as you have still in like very many IT organizations, and then you try to combine it with an agile approach where you basically have those fixed 6 months and you put them in like 2-week chunks, and that's then called Scrum. That's rather complicated than the other piece that we just talked about.
Mm-hmm. Thank you very much, Timo and Yetunde both. I think I had some short question. Yeah, there was some praise from YouTube that Kedro is really amazing. And short question is if there is any official public channel like Slack or something similar.
So currently, we just have a discourse channel. So I also will just post the link for that one, and that's a place for you to like post questions. If there are any feature requests or bug reports, that go straight to our GitHub as well. And I did mention one of the roadmap items we have is opening up a communications channel. It looks like the platform that we're settled on is Discord. So you should look out for that one. If you're following our discourse, it's 2 different ones. I don't know why they named ED. But you will be able to see announcements for when we've actually launched that channel, so that you can hang out with the team, hang out with the community. But our support model for the product actually looks at 1 person staffed every week to monitor all channels or GitHub issues, discourse, and answer any users' questions that are raised. We call that person the Kedro wizard. It's me next week. It obviously gives the product team like first-hand interaction with users in the open source community, so you can mark down like what are they struggling with and what do we need to add to our roadmap and backlog to fix or address. So yeah, you'll definitely find us. And there's a growing community of like Kedro users across the world. So even if we don't respond, like there's someone across the globe that is happy to help.
Great, thanks a lot. So if you could maybe post a link in the chat, that would be really nice. And Timo and Yetunde, if you're open to share the slides, also maybe you could just share the link and I will pass it on to also YouTube people. Alternatively, later after the event. Thanks. So Sadie, finally, please.
Cool. Yeah, I just have a question about the beginning of the process that you talked about. So I'm curious how many of your clients come to you with specific ML AI use cases already, and how many you need to go through identifying the opportunities in the business, and specifically in the second use case where you have to help them identify the opportunities. I know you mentioned mapping out the value chain with them and looking at that, but if you have any more, I would be curious to hear any more concrete, like who are the people you talk to in that case? What are the steps you take to actually find the most impactful areas of the business?
Yeah, that's a very good question. So I think we always start with the value chain, really. And oftentimes you also map internal business processes against that. And then in the ideal scenario, you basically do design research together with an UX designer. So it would be probably me plus a designer, plus in the cases of very technical areas, also data engineer, data architect, or data scientist, and just try to understand what are they doing today. Oftentimes you also pull industry experts in via McKinsey. We've done a lot of use cases. I think we've seen a lot. So I think if we look at the value chain, also business processes, I think naturally we would already have quite a good intuition about like what's possible and like what the major use case would be. And then, so it's something that we would also call like a first day hypothesis, right? Like if you just mapped it out without knowing anything, like what would be your feeling? Like where would you probably have like could you probably get the most impact from, right? And oftentimes like simple things is just like mapping the balance sheet even, or like a P&L against like the different parts of the value chain, because then you know like where value is actually being created the most or lost. Yeah, and then you just try to interrogate it further. Then you, once you've honed in on a couple of areas or along the value chain, you want to understand A, what use cases could be possible in that area, and then B, what data would be needed. If you can get the data, if you can set the technical architecture up to get those use cases off the ground. That's
great, thanks. Sadie doesn't seem to have additional questions. So then one question that I hope maybe you can answer in short. I know we're about to end, but there's one more from YouTube. Is there a telco case you could touch upon from your experience? Any response would be helpful.
Telco, good question. I can have a quick look. I'm not doing a telco, so given my background in medicine, I'm pretty much only doing healthcare, pharma, medtech. But I'm happy to take a quick look in the interim. If you want to go on, feel free to.
Oh no, this one's on you.
Okay, then I think we will be slowly ending. If there is another short maybe question from the group in Zoom right now, you can use your chance. Otherwise, we're about to finish. There were so many questions that we don't have any more time to do the short networking, but come next week and maybe then we have a chance and hopefully can interact a bit more.
So, okay, so the use cases, so if I'm just gonna say like 3 use cases we have done. We've done improvement of network performance across like a big provider. We have done a prediction of service outages. We've done churn prevention and agile campaign development, call center optimization. I think the first two that I just said with the outages and like with the network performance, that's probably very specific. And then you have like a whole array of ML use cases on the back end, I think, which are pretty generic across industries. You could do like financial forecasting, what could be now like marketing and sales, customer churn, all those things. They exist in many industries. They're not specific to telco.
Okay, great. Then thank you for looking into that and checking. I hope that this was helpful to our guests nevertheless. We're now at the end. Thank you very much to Yetunde and Timo for the insightful presentations and for answering all these questions in so many detail. I think it was very helpful to all the guests. Thank you all for coming. We have more events coming up. We're on each Tuesday evening, product management people, on Meetup. Get Product People is our community chat on Telegram. You're welcome to join there, maybe discuss more, ask or exchange experience on using Kedro if some of you have already done that, which I'm guessing from the comments on YouTube that people really like it. And if you like what we do and want to support us, please find us on Patreon, Product People. This helps us to have proper tools to run these events. Thank you all very much. Have a great evening. Bye-bye. See you again.
Thank you.
Thank you.
Thank you.
Bye, guys. Thank you.